either do this homework or yeah, basically do this homework and watch that other video. So this is implicit today. We're going over implicit derivatives. There we are. And these have appeared on the AP exam before, um, but recently they're really not quite as common. So that's just something to kind of be thinking about. Um, Let me see if I can pull this up. Yeah. So really when we see implicit, with them giving us 3 questions, we might get like, a part A or part B on implicit. I don't think we'll have a full question on it, but it's still good practice, good to review. So usually on these implicit questions, they start us off by asking us to find the derivative, but they actually give us the answer. So that's kind of a nice perk to these questions is you're already given the answer. So A says, show that dy dx equals, it gives us that. I like to, when I'm doing these, rewrite the question here. Sorry, I'm trying to use a new app and I'm trying to figure out, there we go. That's what I was looking for. So I like to kind of just go d dx, d dx. All right, so we're taking the derivative of each one of these. So the first one will be the derivative x squared with respect to x, right? Same variables. So we don't really need to do implicit, will be 2x. Technically, it's 2x dx dx, but we don't really need that dx dx part, right? Because that would just be 1. So derivative of x squared is 2x, then plus derivative of 4y squared is 8y. But because these are different variables, then it's dy dx. And that's equal to 0, right? Derivative 7. Plus, now this is going to be a chain rule. So derivative of the first one, 3x is 3. Leave the second alone. Then plus, leave 3x alone. And the derivative of y would be 1, but because the variables are different, it's 1 dy dx. Next, I like to move all of the variables, everything to the left side. So it gives us 2x plus 8y dy dx minus 3y minus 3x dy dx. And then there's the long way and there's the shortcut. The shortcut is just that everything with dy dx is going to stay on the left. So the sign's going to stay the same. And everything without a dy dx is moving over. So we have to flip its sign. Basically, we're subtracting 2x and adding 3y to both sides. And then we would divide by what had the dy dx in. So the shortcut is kind of saying, okay, dy dx is equal to, right, negative 2x plus 3y, because we moved those over, divided by 8y minus 3x. Those don't change their signs because they didn't move over, they're just dividing. You could do that, those step by step, right? You could just say, okay, we wanted to subtract 2x from both sides, add 3y to both sides, right? Those cancel. And then we have 8y dy dx minus 3x equals negative 2x plus 3y. This had a dy dx. And then we would factor out a dy dx. And you divide by 8y minus 3x. And that would still take us up to here. So that's kind of the longer version of it. Now, on the question, it just had the 3y in the front. So because the 3y was in the front, then we would just kind of rewrite that. And that's how they have it written. So that's how we're going to write it. On these, one more thing I do want to point out is they didn't on this question, but sometimes they might just want us to make the x's positive. So they might wanted to have written this as (2x minus 3y) over 3x minus 8y. And that would have actually also been the same. And the way you can kind of tell if it's going to be the same or not is we were starting off with negative 2x plus 3y over 8y minus 3x. And if we want the x's to become positive, we have to factor out a negative. So if we factor out a negative, that changes this to 2x minus 3y. And in the denominator, if we factor out a negative, that changes this to negative 8y plus 3x, which we can just kind of reverse, right? And make 3x minus 8y. And then those two negatives will both cancel to become positive. So that's something too that I have seen a lot where they want us to rewrite it, just kind of different ways of rewriting it. All right. So anyways, this question, there's that. It's usually not too difficult, that first part, but it's just really making sure that we're applying implicit. Part B says, show that there's a point with the x coordinate of 3. And usually, by the way, part A was worth about 2 points, right? They'll usually give you 1 point for like the dy dx parts. And I'll give you a second point for the rest of the work. So B says, show that there's a point with an x coordinate of 3 at which the line tangent to this curve is horizontal. So we're seeing tangent line and horizontal. So as soon as we see, and then it says find that y coordinate of 3. So as soon as we see the word tangent line, we're immediately jumping to x1, y1, and m. And what's going to happen is that our x1 is 1, and our is 3, and our m has to be 0, right? That was given to us. Our m has to be 0. So we want to kind of take that m being 0 and say, okay, we have 3y minus 2x over 8y minus 3x, and that's going to be equal to 0. That's only going to equal 0 if the numerator is 0. But what's the restriction on this? The restriction is that the denominator cannot equal 0, right? 0 over 0 is undefined, not 0. So that is kind of a restriction to this domain. So we just want to check that once we get a final answer. So this is going to bring us down to 3y minus 2x is equal to 0. And they gave us that x was equal to 3. So this would be 3y minus 2 times 3 is 0. 3y minus 6 is 0. So we get y equals 2. So that would be an x1, y1, and an m. Now, we actually didn't really show that lied on the curve, right? We showed that has a slope of 0. But we also need to prove that it lies on the curve. Before we do that, though, we do just want to verify that 8y minus 3x was not 0, right? 8 times 2 minus 3 times 2. We're good. That's 16 minus 6 is 10. So we're good that basically we would have, if we plugged in this point to the slope, we'd get 0 over 10, which is 0, not 0 over 0. Now, it's a show that there is a point at which the tangent line is horizontal. It kind of seems like we did that, but we just do want to be careful because we want to make sure that we're proving that 3 and 2 are still on the original. So that was actually one last point. We got 1 point for setting this equal to 0. And we got 1 point basically for getting this 2. But the third point is that we would plug these into the original, which was 2x plus 8y. No, sorry, that was the slope. The original was x squared plus 4y squared equals 7 plus 3xy. And so just showing, hey, we have 3 squared plus 4 times 2 squared equals 7 plus 3 times 2. That's 9 plus 4 times 4 is 16. So 9 plus 16 is 25 equals, and then 7 plus, that's 18. 7 plus 18 is 25. So yes, 3, 2 lies on the curve. Now, I did this a little bit differently. I did this kind of assuming the 3. And that's one way of doing it. I'm going to pause for a minute and then show you guys a second way we could do this. So just so we can really make sure we're reading it. If we have any questions on this, ask them now. So kind of a second way, which is a little bit of a more common theme, is they're telling us to show that there's a 3. So we're actually going to assume that the 3 is not there. We're just going to do x1, y1, and m. And the only thing really given was that the tangent line is horizontal. Remember, tangent line horizontal means as soon as we see that, that means slope is 0, right? That was how we knew the slope was 0 because we saw that word horizontal. So that's all we're going to assume here. And because of that, then what we can kind of do is we can say, okay, dy dx equals 3y minus 2x over 8y minus 3x, and that equal to 0. And that gives us like we said before, 3y minus 2x equal to 0. That's our first equation. Our second equation is just the other time where we have x over. So our second equation would be x squared plus 4y squared equals 7 plus 3xy. And I know this seems a little weird, but this is very common and we need to be able to do this.
Yo, John, shut your dog.
So, like I was saying, this is a very common thing where we have 3y minus 2x equals 0 from the slope equation, and then we use the original. And this is basically, since they asked us to show that the x coordinate was 3, this will do that because we're not assuming it's 3, we're proving that it had to be 3. So we can solve for either one of these from the top equation. It really doesn't matter at all. I'm going to go ahead and solve for x. So it'd be negative 2x equals negative 3y. Divide by negative 2, we get x equals 3/2 y. And then we would plug this in anywhere we see x. So this would become 3/2 y squared plus 4y squared equals 7 plus 3 times 3/2 y times y. We're going to square everything, so this becomes 9/4 y squared plus 4y squared equals 7 plus 9/2 y squared. And because I really don't like fractions, I'm going to multiply everything by 4 so that I can remove the fractions. So those cancel. Gives me 9y squared plus 16y squared equals 28 plus 9 times 2 is 18y squared. And we'll add our like terms. 25y squared equals 28 plus 18y squared. Subtract the 18y squared over, and we'll get 7y squared equals 28. Divide by 7, we get y squared equals 4. Then square root it, and we get y equals plus or minus 2. Now, when we get two answers, what that actually means about our x1, y1, m is that there are two versions of it. So we want to go back here and put positive 2 as one and negative 2 as the other. And now the way that you solve that is you can plug it into either equation. You can either plug it in. Thank you. Yeah. So we were solving for y. So y1 would be positive 2 and y1 would be negative 2. This one still has a slope of 0. And so now, now we can either plug it in here to equation 1, here to equation 2, or my favorite is to actually just plug it in to where we had solved for it. So we had x equals 3/2 y. So here, x equals 3/2 times y is 2. So we get 3. And this one, x equals 3/2 times negative 2 would give us negative 3. So this is the one we want because it said, show that there is a point with x coordinate at 3, which the line tangent to the curve is horizontal. So this kind of showed it. You could kind of explain if you want. You could say, therefore, 3, 2 is a point. They called it point P. So is a point P with horizontal tangent You don't have to write that. I'm just writing it. We already proved it. So either way is okay. We do need to be comfortable with this way, which is we basically solved it without using 3, but they also did give points if you used 3. The only issue was you had to go back and prove it by plugging it in. This one, we don't have to go back and plug it in because we didn't start with it. We, basically proved it by using these 2 equations. The other one, we never really did this system of equations. We just had plugged in 3 and solved for it. That was a little bit confusing, but it's good practice. So part C then says find the value of d squared y dx squared. And if they do end up doing a full implicit question, you can bet that they're going to ask you to take the second derivative. And then they say at the point found in part B. Now, let's say you got stuck in part B, and then part C says to use the point you found in part B. Just in B somewhere, just make up a y value, like y equals 1. So then you have the point, right, 3 comma 1. That's not the right answer, but because you said that it was in B, you'll get the points in C, right? If you never come up with an answer in B, you cannot do C. Whereas if you did this way, at least you can get the points for C, even though you didn't quite get them all for B. Okay. So anyways, for d squared y dx squared, basically we need to take the derivative of dy dx, right? The derivative, the first derivative would give us the second derivative. So we had dy dx from the original was 3y minus 2x over 8y minus 3x. And to take the derivative with respect to x of both sides here, it's going to be quotient rule because we are dividing. So that gives us low 8y minus 3x d high. Now, when we do the d high part, we have to remember that anytime we're taking a derivative of the y part, we have to add dy dx. So the derivative of 3 is 3 dy dx minus 2, because the derivative of 2x is just 2. Then minus, okay, so low d high minus high d low is same thing. When we take the derivative of the 8, we get 8 dy dx, and minus the derivative of 3x is just 3, all over 8y minus 3x squared. Now, this is something where when we're plugging in a point, I actually just stop here. I just stop here and I start plugging in. If we were not plugging in a point, so I'm going to do this in green. If we were just having to actually solve it out, right? Anytime you get dy dx, you would need to write this whole thing. And we don't need to do this on this one, but I just kind of want to show it quickly. So what you would have had to do here would be multiply everything by an 8y minus 3x, because that's that denominator. Now, it's kind of interesting, and this is where a lot of students get confused, is what is this multiplied to? Well, this is actually basically multiplying, didn't work. So this 8y minus 3x is multiplying to this whole first term, this whole second term, and the bottom. So it's times 8y minus 3x, times 8y minus 3x, and times 8y minus 3x. Now, in this case, we want to multiply it to the second part, but it needs to multiply to these two guys. Here, same thing, it multiplies to the second part, but because of the parentheses, it needs to multiply to both of those. So there's an 8y there. So basically here, 8y minus 3x cancels, but it still does multiply to the 2. Here it cancels, but it still does multiply to the 3. So we get 8 minus 3x times, then the 3 is going to multiply with the 3 to give us 9y minus 6x, and minus the 8y minus 3x is going to multiply by the 2 to give us 16y plus 3x. And we kind of just keep going. I'm going to just put dot, dot, dot all over, and the 8y minus 3x is going to become cubed. Now, the reason I'm showing that is to show you why you should not do this. You're going to get lost. You're going to make a mistake. And it's just way too much work. The graders do not want you to do this. It's way, 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 way too much work, and it's just not worth it at all. So please, please, please do not do that. All right, what we're going to do instead is that once we get to what we had in blue, right, as soon as we've taken the derivative, once we've taken the derivative, now we're going to plug in our point, right? Because they wanted d squared at point P. Well, point P was 3, 2. So as soon as we get this answer in blue, we're going to plug in 3, 2. So that's going to give us 8 times 2 minus 3 times 3 times 3. Now, dy dx is the slope. So I can't plug in 3 or 2. I have to go and find the slope. Well, what was the slope? Our slope was 3y. So 3 times, we're going to plug it in there. 3 times 2 minus 2 times 3 over 8 times 2 minus 3 times 3. This is probably the hardest part of this. So that gives us 6 minus 6 over 10, which is 0. Now, if you were smart about this one, and a lot of times they do this, you actually didn't have to do this. If you were smart, you could have just realized, hey, wait, in point B, it was horizontal, the slope was 0, right? And in like our x1, y1, m, we had already found that it was 0. So if you plugged it in, you'll get 0 anyways, but if not, we kind of should have known that. So 3 times 0 minus 2, and minus 3 times 2 minus 2 times 3 times 8 times 0 minus 3 all over 8 times 2 minus 3 times 3 all squared. So we'll go ahead and start trying to simplify. That part's going to go to 0. That part's going to go to 0. This is 16 minus 9. 16 minus 9 is 7. Times this is 0 minus 2. So 7 times negative 2. Minus, and 3 times 6 is 6. Minus 6 is 0. Anything times 0 is just going to give us 0. All over. And then the denominator, 8 times 2 is 16. Minus 9 again is 7. So all over 7 squared. You could cancel out the 7s, right? Because this 0 is kind of gone. So you could just make it negative 2 over 7 by canceling them out. Or you could just say it's negative 14 over 7 squared. And if you want to leave that as your answer, that's a perfect answer. If you're comfortable and you want to make it negative 14 over 49, that's also a fine answer. You don't need to simplify this. If you did simplify it, you'd get negative 2/7. Now, one thing I mentioned yesterday is after we do this, a lot of people stopped here. You actually didn't finish this question. So after we do this, let's go back and just make sure we reread it, right? And when we reread it, there is a second part of this question, which is, does the curve have a local maximum, a local minimum, or neither at point P? Now, you can do this one of two ways. The easiest way is actually that second derivative test, which I told you guys we really only use about like 1% of the time. So I usually don't even remember about it. But it's where if we know that we have a horizontal tangent on our graph, right, a place where the slope is 0, then if it's concave up, then that point's going to be a minimum. And if it's concave down, that point's going to be a maximum. Well, because this was the second derivative, we know that that's controlling concavity. So what we can say is by the second derivative test, 3,2 is a maximum because basically y prime equals 0, right? That was our first step. And y double prime is less than 0, so it's concave down at 3, 2. So that's our second derivative test. The only time I've ever seen the second derivative test appear is on multiple choice, which we don't have to worry about, and on implicit questions. So that's really the only time I've ever seen it. You don't have to do it, but if we forgot about the second derivative test, the alternative is a little bit longer. So let's say we totally forgot about this rule. Right, the other way to find maximum or minimums is basically to set y prime equal to 0, which we kind of did. And we got the point 3, 2. Right, and then this is where it basically is a little kind of weird because we're plugging in x values, right? So we're plugging in 3. We need to plug in something smaller than 3 to the derivative, right? The issue here is that if I plug in 2, right, well, the derivative was 3y minus 2x all over 8y minus 3x. And if I want to be able to plug in like a smaller value, like say 2, I need to know what is that guy's y value. So we would need to plug it in to the original and solve for it. And we might not even get a whole number, right? We might get a fraction. So it makes it a lot more complicated. Then same thing when we plug in 4, we would need to plug it into the original and find a y value. I don't want to waste all of our time doing that. It's a lot of work. But you would find a y value, and then you would just check the signs. Is it positive or negative? You'd get positive, you'd get negative. So you could say it's, 3, 2 is a max because y prime changed from increasing to decreasing at 3, 2. Actually, y prime did not change. Don't make that mistake. y prime did not change from increasing to decreasing. Y prime changed from positive to negative, right? It was positive, now it's negative. Y was increasing and then decreasing. So that's probably a much worse way to do it than the second derivative test, but just throwing it out there because a lot of us won't have remembered it. So we're gonna go through these next two much, much faster, but I want to spend a little more time on the first one. Do we have any general questions, or we're feeling all right with that? I know this is just something where it's kind of been a while since we've done these, right? So, okay. So next one, kind of same thing. I like to first write out our equation and then kind of just write in d dx to each term. If you wanted to write that up here, that's fine too. You know, write in each spot. Just some way to make sure you remember what we're doing. So first one is product rule. So derivative of x is 1, leave y squared alone, plus now leave x alone. Derivative of y squared is 2y dy dx. Now, this next one is something that, because a lot of people do what I did, and they write the d dx here, they miss a negative and they get this whole thing wrong. So if you're solving for this and you don't get that, you get something else, the first thing that you want to check is that you distributed that negative. Because this negative, when we're doing product rule, it needs to go to both products. So a good idea is to just kind of make this a plus and put the negative in with the x. That'll basically solve your problems. So I'm going to just put plus derivative of negative x cubed is negative 3x squared times the original is y, and plus the original, the first one is negative x cubed, right? Because this was product rule, times the derivative of y is just 1 dy dx equals to 0. If you didn't do that, you would have had to make sure that that was negative and that was negative. If you hadn't put the negative in with x. So this is now, as we simplify, y squared plus, I'm going to bring the 2 to the front, 2xy dy dx minus 3x squared y minus x cubed dy dx. And on this one, I'm just going to do the shortcut. I'm not going to show the long way. So I like to underline the dy dx terms. The other terms will flip. So it'll be, I'm going to put this one first because it has an x and because it looks like the one with the x with both of them went first. So when we flip it, we get 3x squared y minus y squared, right? We're flipping those guys' signs all over. Then the other two keep their signs, 2xy minus x cubed. And that's our answer. So we've proven it. We don't have to do any more work. Next one says, find all points on the curve whose x coordinate is 1, and then write an equation for the tangent line and at each of these points. Okay, kind of rhetorical question. You don't have to answer this, but what do you think of when you see at each of these points, right? You would think that there's more than one answer. Same thing with find all points. You think there's more than one answer. And whenever we see tangent line, right, this is where we're thinking x1, y1, and m. So tangent line, we're thinking x1, y1, and m. X1 they gave us was 1, right? So in order to figure out the y1 and the m, we have to plug in that 1 back into the derivative and to the equation, right? So we know that the original equation on this one was xy squared. All right, let's zoom out a little bit. Xy squared, oops, minus x cubed y equals to 6. And then our derivative was basically m equals 3x squared y minus y squared over 2xy minus x cubed. So those are the two kind of equations we're working with. Now, we can't plug in the 1 for m because there are basically 3 variables, right? M is a variable. We don't know the slope, but we can plug it in to the original equation. So you make this 1y squared minus 1 cubed y equals 6. That gives us y squared minus y equals 6. And anytime we have a quadratic, this is back to like math 2, math 3, maybe even math 1. Right? We set it equal to 0, and you do whatever kind of factoring you do. I really don't ever remember how to do that properly, but you guys can do it if you like it, as long as we get y equals 3 and negative 2. So this goes back to what I was saying before, is actually we're going to have 2 tangent lines. So I'll do the other one in blue. And this one will have a different m, so I'm going to kind of put m2. So for my first one, we'll say it was 1. We'll use the 3. And the second one, we're going to repeat the 1, right, because we plugged in 1. But now we're going to have negative 2. So for our first guy's slope, we're going to plug in 1 and 3. So 3 times 1 squared times 3 minus 3 squared all over 2 times 1 times 3 minus 1 cubed. That gives us 9 minus 9. So in the numerator, we got 0. We just need to double check that the denominator is not 0, right? 6 minus 1 is 5. So we're going to get a slope of 0. Okay. And then for this let's finish that one. So what equation, right? Because they asked, let's just make sure that we're looking at it. It says write an equation. That's actually what they want us to do, is write out the equation. That's kind of the answer they're looking for. They're not looking for the whole x1, y1 setup. They're looking for the equation, right? In this one, they were not looking for the equation. They were just asking us to show that there's a point and find that point. But in this one, they want us to finish it with a full equation. So that would be y minus y1 is 3 equals 0 times x minus 1. If you want to leave it like that, you can. If you want to simplify it, on the AP exam, they just multiplied that 3 to get, basically 0. So y minus 3 equals 0. And they added the 3 over, so they got y equals 3 as the actual equation, but this is fine. Okay. Then for our second one, we're going to do the same process, right? We're going to plug in 1 and negative 2. So 3 times 1 squared times negative 2 minus negative 2 squared all over 2 times 1 times negative 2 minus 1 cubed. That gives us 3 times negative 2 is negative 6 minus 4 over negative 4 minus 1. That's negative 10 over negative 5, which is positive 2. So now from there, this is going to give us y minus negative 2 is going to turn positive, so y plus 2 equals 2 times x minus 1, and we're just going to leave our answer just like that. So, like I said, good practice is to just go back and make sure we answered it. Find all points on the curve whose x coordinate is 1, right? If we want to be nice on the reader, we could say that, as points, kind of, we have 1 comma 3, box that. We have 1 comma -2, box that. But we did that, right? Like we had found those points. And write an equation for the tangent line, we did that. So we've answered this question fully. Okay. And see, this is the one I've been waiting for. This is kind of the weirdest one, but it does appear on some of these, is find where the tangent line is vertical. Well, and they only want the x coordinate. They don't care about the y coordinate here. And it's actually because the y coordinate doesn't always exist. Sometimes it does, sometimes it doesn't, right? For this graph here, this is x cubed, right? If we kind of inverse this, it becomes the opposite of this, which is with a vertical tangent there. So that's what a vertical tangent might look like. Here it does exist, but sometimes you'll also solve for a vertical tangent. It'll be also at a vertical asymptote, which is a little bit weirder. But that's kind of what our vertical tangent might look like. So they only wanted the x coordinate here. So anyways, anytime I see tangent line, I immediately jump to x1, y1, and m. And vertical line tangent means that the slope is undefined. Well, the way you're going to get an undefined slope is when the denominator is 0. So, right, if this is going to be dne, what that really means is in order for it to be dne, the denominator, the bottom, has to be 0. So 2xy minus x cubed needs to equal to 0. Now, this is one equation. I can't do anything with it yet. So we need to use our second equation, which was the original xy squared minus x cubed y equals to 6. And this is basically like in math 1, we did these with substitution, elimination, graphing. This is like the calculus version of that. And so we need to pick out what's the easiest variable to solve for. Well, in the first equation, x would suck to solve for because there's an x and an x cubed. But y is all by itself. It's going to be pretty easy to isolate. In the second equation, we have an x and an x cubed. That's going to suck. We have a y squared and a y. That's also going to suck. So the only option for us is to isolate y in the first equation. So we're going to add over the x cubed and divide by 2x. That becomes y equals x squared over 2. And now we've isolated the y. Now we can plug that in where we see y in the second equation. So we're always doing substitution on these. You can't do elimination. And these, if they're not a calculator question, you cannot plug it into your calculator. So this becomes x times x squared over 2 minus x cubed times, this was squared, right? Y squared. X squared over 2 equals to 6. This gives us x times, when we square it, we get x to the 4th over 4 minus x cubed times x squared is x to the 5th over 2 equals to 6. This is x to the 5th over 4 minus x to the 5th over 2 equals 6. I don't like fractions, so I'm going to go ahead and multiply times 4 times 4 times 4. This gives us x to the fifth minus 2x to the fifth equals 24, which is negative x to the fifth equals 24. If I divide the negative, I'll get negative 24, and then we just take the fifth root of it. And we get x equals the fifth root of negative 24. I know that seems weird, but that's actually the answer. And they just wanted us to stop there. Now, this was number 5. It was a non-calculator question. But at the same time, okay, I'm kind of anticipating that our AP exam might be calculator. So if that does happen, I just want to review very quickly how we would do this in red if we had a calculator, and it's way, way, way less work. Okay. And I mentioned online, but if you guys want to get this software on your computers, I believe they're giving a 6-month free trial right now for students and teachers. Or there's also an iPad version, which they're making free through April. So anyways, in menu and then in algebra, there's solve system of equations. They're not linear, so we're going to pick the first one. We have 2 variables. They were x and y. And then from here, we would just type in these 2 equations. So we would go ahead and type in two xy minus x cubed equals 0. And then xy squared minus x cubed y equals 6. And okay, this is really important. So I'm glad I did this as an example because a lot of you guys will get this mistake. You're like, what the heck? I didn't get an answer. Okay. The reason you're not getting an answer is how this deals with variables. X is a variable. Y is a variable. X, Y is a variable. You could name a variable Steve, right? They're all being italicized as variables. Whenever we do this, we actually need to make sure that anytime we have X and Y together on our calculator, we click the times button, the multiplying symbol, to separate them so they treat them separately. So now there's our answer. And that x equals negative 3 to the 1/5 times 2 to the 3/5, that's the same as fifth root of negative 24. So it's 1.88. And if we do 24, the fifth root would be to the 1/5 power. We'll get that same 1.88. I forgot to put the negative in. But we see that those are the same answers. So that's how we would do that with a calculator. Okay. This last question we don't have time for. It's okay. Just looking at it, part A is the same thing we've been doing, right? Part B, we see a tangent line. We do x1, we would do y1. We do the slope. The slope is 1/2. So we would be doing is we would have y over 2y minus x is equal to 1/2. That's one equation. I'd probably multiply both sides by 2. Right? That's one equation. Our second equation is always going to be the original. So in this case here, we have 1x. We can isolate x and then plug it in over here. We're not going to go through that, just kind of talking about it. C says show that there are no points where the tangent line is horizontal. So same thing, we would have x1, y1, and m. This time m is 0. We're going to do that same exact process. But when you do this, you should end up with an answer like 2 equals 6, which is false. And so that shows that nothing actually worked, right? You won't get an answer. And C says, let x and y be given by these functions. And at time t equals 5, the value of y is 3 and dy dt equals 6. And then find the value of dx dt. So in this case, instead of doing implicit with x's, we're doing implicit with t's. I'm going to just set this up quickly and then we'll be done. Right? We have to take the derivative with respect to time because they're now saying that they're functions of time and they're giving us a dy dt. So in this case, we'd get 2y dy dt equals, that goes to 0. This does product rule. Now, the derivative of x is normally 1, but when we're doing with respect to time, it's 1 dx dt because these are different variables. And then times y, and plus, now we leave x as original, and then this is dy dt. I'm not going to finish this one, but they gave us a y value of 3, so we can plug in y. They gave us a dy dt, so we can plug in dy dt. We're solving for dx dt, we can plug in y, we can plug in dy dt. We need x. So in order to get x, though, we have an equation, and we know y is equal to 3, so we can solve for x to plug it in. So you're going to plug that in once you solve for it. Okay. My computer's about to die, and it's 9:30. So we are going to log off. Before we do that, basically what I'm going to do is I am going to create 2 assignments. I already created the first one. And the first one is that you're going to watch the video at see if we're still logged in here. I'll just go over it. It's easy enough. So the first one is that you're going to watch the video. Your homework is going to be to post the notes of that video. And the second one, right, so that's here. So just, you can go ahead and instructions, click on that link, and you're going to watch this video. It's at 11. It does say 2 o'clock if you look on the official site, but that's because they're using the Eastern time, right? Our time, Pacific time, is 11. You can watch it live or you can watch it later, but your homework here is going to be to take notes. Okay, I'm going to post a second assignment. The second assignment is only for the people who missed this video. For you guys, you were here. We already did these 3 questions. They're going to also have to do these 3 questions because they missed this video. So for you guys, though, in order for me to grade it, what I have to do, yeah, the video will be uploaded after. So if you miss it, if you miss the video, you can't be there at 11. That's totally fine. You guys already were here at 8:30. I don't expect you to use your whole day on calculus. So if you want to watch it tonight at 9 p.m., that's fine. It's going to be uploaded. You don't have to take notes on every single thing they say. Really, all I'm looking for is evidence that you watched it. If you guys want to, honestly, if you want to miss it on purpose so you can watch it at 2 times speed, that's probably a better idea anyways, right? And then you can pause it and do what you want to do. So my recommendation is, if you really want to be on at 11, great. If you want to wait later and then watch it at a faster speed and pause it, take your notes, that's great. You don't need to take super detailed notes, just anything new that you didn't know before this, take notes on. If you felt like you knew everything, just take a little bit of notes so that you can prove to me that you watched it. Okay. And then the second assignment will be on this worksheet here. You guys don't need to do anything. I already know who was here from the chat log or the participant log. So what I will do is for you guys, just put turned in, maybe add a comment like, I was in the video or I was in the Zoom, and then I'll give you a 5 out of 5 for worksheet 108. Okay. And then the other thing I am going to ask you guys is tomorrow, let me know